Hello laser enthusiasts, this is Chris in Doha, Qatar, back with another video. Been a while, but I just had to share this with you. I'm introducing the laserdiscourse.org forum at the same time, showing you this really nice but inexpensive spectrometer. It's called the i-Phos HD for high definition. If you go over to the laserdiscourse.org forum and look under reviews, you'll find my review here. You can get black, gray, green. I think there's another color, but he has several colors you can order. And you can order an optional slit where you can change out the slits to different sizes from as small as a 0.5 millimeter and on up. There's also some software you can get with it. You can download for free. He doesn't make the software, but he'll give you a link for it. I believe I'm pronouncing this right, Theramino. Maybe not, but that's the group that makes this open source software, and it's really good because you can calibrate it using a simple fluorescent lamp, which produces a spectrum. You can see it here. There are a couple lines of mercury lines, 436 nanometer and 546 nanometer, that are always the same on these bulbs. These other lines in energy will display also, but they can move around a little bit from bulb to bulb, so you just use those two to calibrate it with. And when I did so, I was showing the spectrum just perfect for a few of my laser pointers that I knew the exact wavelength that they would put out, and it worked really well. In this review, I'm comparing this i-Phos HD to a professional $1,500 spectrometer, and most spectrometers go for more than that, even the lowest priced ones. That's just the number I came up with. I don't think you'll find them cheaper than that for professional level. I have several pros. I have 5. I won't read them to you here, but you can go and look at my review at laserdiscourse.org. There's 3 cons. 2 of them are really moot for what I want to do with this meter. The third one is also somewhat moot, considering it's just that the peak power displayed on the software is not linear in some portions of the spectrum. This will cover from 370 through 950 nanometer. So it's not quite as good that way. A professional unit would use a line camera, and they're more accurate for the actual power that you're measuring. But it doesn't matter to me because I bought this to measure wavelength, not power. If I want to measure power, I use a laser power meter, which uses a thermopile. I go into the operation a little bit. Screenshot here of I'll call it UV diode. It's actually slightly above because UV starts at 400 and below, but it's a 405 nanometer diode that if you push the power output to 1.5 watts, that this particular diode will take. I know that's a lot more than rated if it's 300 milliwatt, but this one will take it and last long enough for our use in laser pointers that we don't worry about pushing them hard. But it slides up a few nanometers. It goes up around 411 nanometers, and this spectrum showed that. Just what I was told when I bought it, it would do that, and it did. I also took the spectrum of a cheap 532 nanometer laser pointer that does not have an IR filter in it, and it did show the pump diode energy, the 808 nanometer, in addition to the output, the normal green at 532. This is the spectral response of a CMOS camera. They're all about the same. Just wanted to show you that. So if you're measuring into the IR, the instrument has lower and lower sensitivity if you're going into near IR, longer wavelengths. But you can see way over here at about 10.5 or 1050, it's very, very low. But it didn't matter at all because I was able to measure a 1064 nanometer pointer just fine with a very large response. I'll show you that now. Here's the spike at 1064 nanometer. There's plenty of power there, even though it was far beyond the advertised wavelength that this could go to into the near IR. Still measured fine. You can calibrate these with a fluorescent lamp. This is one. They come in different shapes. But there again, there's the spectrum they put out. We use the 436 line and the 546 nanometer lines because they don't move. There's a summary there. And then a little bit of conversation in the forum about the post I made on the review. So please come on over to the forum. We're brand new. There's not that many members right now. We'd like to have more. We're becoming, although that's what the case is right now, we are becoming more active, and we invite more members to continue in with us on our conversations and post what you're interested in, and respond to some of the posts that are already made. There's quite a few actually. Okay, cheers from the desert near Saudi Arabia, Doha, Qatar.